In this product demonstration, we will examine how Watson Analytics can be used to help analyze graduation data from the Compass for Success data warehouse. For this scenario, we will be playing the role of a researcher at a school board trying to uncover patterns in the data and decide what early interventions should be implemented in order to have a positive impact on graduation rates. The Compass for Success data warehouse includes many data sets for analyzing student achievement, and using Watson Analytics accelerates the analysis I have to perform by loading directly from the trusted Compass for Success data warehouse and analyzing the data for me. In seconds, Watson Analytics can uncover the drivers within this complex data set. I'm starting the demonstration in Watson Analytics, where I've already uploaded my data. The first thing that Watson Analytics does is provide suggested starting points. These are entry points into the data that Watson Analytics has uncovered and has determined to be of interest. It should be pointed out that these starting points are unique to each data set used. To start the analysis, I can pose a question to Watson Analytics in plain English. In this case, I want to ask, what students graduated? Watson Analytics automatically analyzes my question and provides the relevant visualizations. In this case, I'm going to choose the first one. Watson Analytics automatically created a simple column chart that displays the breakdown of students that have graduated. Since I want to see the historical trend, I can add cohort year as the multiplier. This shows me the historical trend for the cohorts I have data for. Similarly, I want to understand the breakdown of gender, so I can set gender for the color by region. When it comes to analyzing data across schools and school years, it may not always be a fair comparison because schools have different enrollment numbers. In order to account for this, I can always choose to visualize my data in a stacked 100% format. I want to create a similar analysis, so I'm going to duplicate it and rename it as graduation by exceptionality. Instead of looking at gender, I want to change the display to show exceptionality. In this case, I'm only interested in students that have an exceptionality, so I'm going to exclude the values NA and no exceptionality. I can see that in the first cohort that there were more students that did not graduate than those that did. However, the following 2 years saw more students with an exceptionality graduate than those that did not. This is a promising trend. There is an interesting data point that we have for which I've been curious about its relevance. It is the number of years a student has been with the school board prior to starting grade 9. I'm going to pose another question. How does number of years with the board compare by school? I can see that this visualization is displaying all of the high schools across the top and the ranges of years the student has been in the board across the rows. In this case, the darker the color represents more students. Since I only want to look at students that have graduated, I'm going to set the graduated column to yes. I can see that as the number of years increase, the color gets darker, which tells me that the longer a student is in a school board, the more likely they are of graduating. Now, the analysis that we've done so far is similar to what can be done with Cognos and other business intelligence tools. The real value of Watson Analytics is how it can analyze our data and uncover the drivers. I want to ask it a more specific question of what drives graduated? I'm now presented with a new starting point that looks like a bullseye. I'm going to select it. This visualization is called a spiral graph. The way it works is that the dotted line spirals inward toward the center. The closer a data item is on the center, the more significant it is. I can see that the furthest point out includes school name, whether or not the student was enrolled in grade 4, how old they were in the second year of high school, their exceptionality, First Nation status, the number of years with a school board prior to grade 9, and the number of times that they were late in grade 7. As I move further in, I can see more significant drivers, like the results of grade 10 OSSLT exam. This basically means that if Watson Analytics knows the OSSLT results, it can predict with 83% confidence whether or not a student will graduate. It is also worth noting that as we go through our analysis, Watson Analytics is always suggesting other insights that are relevant within our current context. I can see that it is suggesting a predictive decision tree for further analysis. The decision rules outline in plain language the rules for who is likely to graduate. On the flip side, I can change the target category from yes to no to see which students did not graduate. Looking at the three scenarios, I can see that the students that are not graduating are the ones scoring poorly on the EQAO OSSLT standardized test and had high numbers of both late and absenteeism in grade 4. I can also visualize the flow in a decision tree where I can see that blue represents the students that did not graduate and green represents the students that did. As a researcher, Watson Analytics called out the significance of the grade 10 OSSLT standardized test results and the early indicator of grade 4 attendance. I'm now in a position to investigate these key points further with my colleagues and discuss the intervention strategies that we can implement. These insights are a good starting point, but I want to push Watson Analytics a little further. Often identifying graduation drivers in high school is too late to take action. So I took the same data set with a graduated flag of yes, no, and removed all of the high school data. This means that we can look to prior cohorts and understand the drivers that are within the elementary data sets. At a school board level, we can run this analysis and predict which students may struggle in graduating before they even start high school. I'm going to use this data set now and pose the exact same question I did previously. What drives graduated? Now when I run the visualization, I get the drivers against the elementary dataset only. I can now see that if Watson Analytics knows the number of years a student was with the school board prior to grade 9, along with the number of times they were late in grade 4, it can predict with 82% confidence whether or not a student will graduate. I can drill into the underlying details to see how the data is distributed. In this visualization, the number of years a student was with the school board prior to grade 9 is distributed across the rows, and the number of times a student was late in grade 4 is displayed across the columns. For any intersection, the students that did not graduate is displayed in blue, and the students that graduate is displayed in green. If I want to see the statistical tests that Watson Analytics is running to determine these drivers, I can display the analysis and see the details of these statistical tests. To make analyzing graduation data in Watson Analytics even easier, Compass for Success has created an expert storybook which provides the visualizations and analytics to analyze graduation data. Since all hosted and non-hosted Compass for Success school boards share the same data model, it is easy to connect their data into Watson Analytics. This means that more time can be spent on analyzing the data instead of managing it. Upon opening the storybook, I'm presented with the analytics that are available to me. Jumping into the graduation dashboard, I can see similar visualizations to what was built at the start of this demonstration. Instead of having to assemble these visualizations, the storybook makes it easy to click through the visualizations and see the story that the data is trying to tell. Graduation trend by school shows me the graduation trend of high schools within the board. The Demographics tab displays the breakdown by gender and by exceptionality. The heat map displays the correlation between high school graduation and the number of years with the school board prior to grade 9. The Drivers and Predictions tabs illustrate the predictive models that Watson Analytics built for us. Navigating to the next series of analytics, I am presented with the drivers when using just elementary data. The last set of visualizations in the storybook deal with post-secondary applications. The first visualization illustrates the post-secondary institutions that students within the board applied to. This is useful for understanding the overall trend. We can drill into more detail by cross-referencing the post-secondary institutions with the high schools students applied from. The heat map outlines this relationship with the darker color representing more applications. This visualization is powerful in understanding where students are applying, but may also provide insight into the types of programs they're interested in. Knowing that a high proportion of students in Secondary School 3 are applying to Georgian College may show that there is an interest in automotive programming and may help shape the type of curriculum being implemented at the local high school. You should now have a better understanding of Watson Analytics and how the Expert Storybook for Graduation from Compass for Success can help to uncover the drivers within your data. Thank you.